Hi folks, today we're having a look at the National 5 topic of scientific notation. You may have previously heard about this topic as being called standard form. That is the same thing. So first of all, we need to make sure that we have some prerequisites for this topic, making sure that we can write a number in scientific notation and turn it back into normal form. The next thing we're going to be having a look at today, more into the National 5, you'd be expected to perform calculations on your calculator with scientific notation, and quite often these would be given in context. So let's have a look first of all at the basics. So as we said, scientific notation and standard form are the same thing, and these are the process of changing very small or very large numbers into a form that looks like this. So it's a number times 10 to the power of another number. So the A value should always be a number that's between 1 and 10. Often that will be a decimal. And the N value is an integer. That means it can be a positive or negative number. And this will tell us about how the number has changed, how the number has moved places, or the decimal point has moved places. Okay, having a look first of all then at large numbers, just to recap for us. When we are turning a large number into scientific notation, I would be expecting to see some number times 10 to the power of. What we do is start with the decimal point on the end here, and we jump across until we make a number that is between 1 and 10. So 9.2 would be the correct number in this case here. And if we count, we have jumped over 6 places, so that means that the power is 6. So it's a very repetitive process once we have that under our belt. Okay, example 2 then, doing the same process. 1, 2, 3 places gives me the number 1.26 times 10 to the power of 3. We then need to be able to turn numbers from this form back into our full normal number form. And we do that by moving the decimal point back again. So in this case, we're moving it back 5 places, which means we end up with 14000. A wee tip there is that if you have a power of 5, then you should end up with 5 digits behind where the decimal point had been. Okay, and the same with the second example here then. If I move the decimal point back, I will end up with 3, 8, 2, 0. Not sure why that's gone thick there. Okay. Next, we want to be thinking about very small numbers, and the process is similar here. There's just one slight change, and that is that to make a number between 1 and 10, we need to move the decimal point the opposite direction, so we have to go to the right. So we would start off with still 2.5 is my number between 1 and 10, times 10 to the power of, but in these cases, instead of writing 3, we write negative 3 to show that we've moved the decimal point in the opposite direction. Okay, example 2. Similar idea again. We want to move the decimal point, and this will become 3.56 times 10 to the power of 1, 2, 3, 4, 5. So that is negative 5 in this case. And the last thing that we should already be able to do is turn those back into full. So again, this time we want to move the decimal point to the left 4 places to put it back where it was. So that means that we have 0.00027. And just check, 1, 2, 3, 4. Yes, that works. Okay, so 0.00027. And then the same with the last one. If I move my decimal point 2 places back again, I will end up with 0.0305. A good tip with this one is to look at the number, and if the number is the number 4 there, then you will actually end up with 4 zeros here in the answer. If the power was negative 2, then you end up with 2 zeros in the answer. But the first one will always be in front of the decimal point. So they're just a couple of shortcuts for you. Okay, so moving on. we need to be able to, in National 5, look at calculations in scientific notation. And to do this, you need to get to know your own calculator. So there are many different models that you could be using here. What I have selected are just two of the most popular models that we see at the moment. There might be different colours, but Sharp and Casio tend to be the most common calculators that we see in school. So if I wanted to type in my calculator, let's say 3.2 times 10 to the power of 6. There are several ways that we could do this. We first of all need to type in 3.2, and we could just type in times 10 as normal and then find the power button. Now on some calculators the power button is this one here, y to the power of x, or on this one here it is x with a wee square, and then just type the number 6 equals. Some calculators there is another symbol, and that symbol is just an up arrow to put in your power there. So one of those three buttons and then put in your power of 6. It's easier if you use another button, however. And what we would do, instead of having to type times 10 to the power of and then your number, is you can actually just type in 3.2, and then on your calculator you will either have EXP, or there's a button on the Casio down at the bottom here which is times 10 to the power of, so either EXP or times 10 to the power of, it might be a box on some calculators, and then you just type in the number 6. So it's far fewer buttons for you to type in. Okay, so that is handy for us to be able to use. What will also be useful for you in the next few examples will be knowing where your brackets are on your calculator. They will be handy. And also your negative button, if you're putting in a negative power. We don't use the take away, we use the negative, which is either the negative in brackets on the Casio or the plus minus button on the Sharp. So it's useful to get to know where those buttons are on your own calculator. Okay, so going to our first question in calculations for scientific notation. This is a grade C question, just calculate what is this. Now most of the questions in scientific notation will also ask you to provide an answer in scientific notation. And that's really where your mark is going to come from in this one here. They tell you what the calculation is. You need to type it into your calculator. So I'm using a Sharp calculator just now. So I will type in 4.8. You don't need to write this down. It's just for the sake of telling you what I'm typing. EXP 5 times 1.7 to EXP 3. And you may want to put those in brackets. It depends on your calculator. And this is why I'm encouraging you to get to know your calculator. Okay, so this section doesn't need to be written down, but just so that you know what I'm typing just now. So 4.8 EXP 5 multiplied by 1.72 EXP 3, and I get a big long number. I get 825600000. As I said previously though, we would be expecting this answer to be given in scientific notation. So you then have to recall that work that we were doing previously and jump over, imagining your decimal point on the end. We would jump over 1, 2, 3, 4, 5, 6, 7, 8 places to get 8.256 times 10 to the power of 8. Okay. So it's more likely that we'd be asked to look at questions in context if we were going into an exam situation. Quite often these contain some basic knowledge outside of the National 5 course. So it might have things like time, distance, speed, maybe a bit of ratio and proportion. You might need some basic knowledge on fractions and percentages, which are things that you have done in National 5. Okay, so a few exam questions for you to have a wee look at. A snail crawls 3 kilometres in 16 days. What is the average speed of the snail in metres per second? Give your answer in scientific notation, correct to 2 significant figures. So I've highlighted the key information here. This is 16 days, but our answer is actually going to be in metres per second. So we are going to have a little bit more work to do here than we might initially think. This also says metres, but we're talking about kilometres. So if a snail can crawl 3 kilometres in 16 days, and we're trying to work out the speed, you need to be able to recall your old formula of speed equals distance over time. The distance here is 3 kilometres, but we're going to be given our answer in metres per second. So I'm going to change that into 3,000 metres. So remember that there is 1,000 metres in a kilometre. And the time is 16 days. Again, we want this to be in seconds. So first of all, multiply that by 24 to work out how many hours that is, because we have 24 hours per day. So 384 hours. If I multiply that by 60, that will tell me how many minutes we have in 16 days. And then I'm going to multiply that again by 60. And that tells me that I have 1,382,400 seconds in 16 days. Okay, so I will then put that into my formula that I started off with. Distance is 3,000 divided by the number of seconds is 1382400. And if I type that into my calculator here, I get an answer of 0.002170138. Do bear in mind that that number may continue on. It's just that your screen cuts off there. We're asked to give that answer in scientific notation, but also to 2 significant figures. So I might round that first of all to 2 significant figures. If we didn't want to do it all in one go, that is fine. That would become 0.0022. And then in scientific notation, that is 2.2 times 10 to the power of negative 3. And this is metres per second. So a fair bit of legwork on what we first thought was a short question. Okay, let's have a look at another one. You can see here this is from the 2019 question paper. A sesame seed weighs 3.6 times 10 to the power of negative 6 kilograms. The weight of a poppy seed is 8% of the weight of a sesame seed. Calculate the weight of a poppy seed in kilograms, giving your answer in scientific notation. So the poppy seed is 8% of the weight of the sesame seed. So we need to calculate what is 8% of 3.6 times 10 to the power of negative 6 kilograms. So to do this, 0.08 multiplied by 3.6 times 10 to the power of negative 6. And I would just type that straight in my calculator. So 0.08 multiplied by 3.6 exp negative 6. And that gives me 0.000000288 kilograms. And just remember that we're asked to put this in scientific notation. So this is going to be 2.88 times 10 to the power of negative 7. So So hopefully through the use of that video and my examples there, you are now going to feel quite confident in using scientific notation and changing between normal form and scientific notation, and be able to go on and try out some questions on your own and practice on your calculator, the calculations in context.